Hello everyone. So today's topic of discussion is valence bond theory. This is a subtopic from chemical bonding and it's important from ITJ main advanced point of view. I hope this is going to help in your future. Valence bond theory, as the name is suggesting that this theory deals with valence orbitals and their overlap. This theory was firstly presented by Hitler in London and later it was explained and expanded by Pauling and Slater. This theory tells us that a covalent bond is formed by the overlap of half-filled valence orbitals of the atoms which are being combined having one unpaired electron with the opposite spin. This theory is based on quantum mechanical model, the one which we studied while doing Schrodinger's wave equation. And thus we can also conclude that more is the overlap possible between two valence orbitals, stronger will be the bond formed and the bond length in result would be smaller or shorter. Now based on different types of overlapping possible, there can be different bond formed. Sigma bond. A sigma bond is formed by the head-on overlap. And thus there can be a case of SS overlap, SP overlap, and PP overlap. And in other case, there is a formation of pi bond, which is formed by the sidewise overlapping between the valence orbitals. And from this we can conclude that a CH4 molecule, a methane molecule should have 90-degree angles in it as it contains 3 p orbitals which should be at 90 degree to each other, and thus CH bond should not be similar to each other as there are cases of two different types of overlapping here. 3 bond lengths will be similar where there is overlapping between S and P orbital, and there is another bond length which is different from these three, which is SS overlap. But the structure doesn't match with experimental data of methane. This leads to the concept of hybridization. So it's a process of intermixing of atomic orbitals of different energy or nearly same energy to form equivalent sets of orbitals which would be now having the same energy, identical energy, or equivalent energy and identical shape. So based on this, we can now say that CH4 molecule would look like this, where there is overlapping between s orbital of hydrogen and sp3 hybridized orbital of carbon, and the structure would orient itself in a tetrahedral manner with a bond angle of 109.28 degree. And all the CH bond lengths would be similar in this case and would be of same energy. Okay, also we can say the number of hybrid orbitals would be equal to the number of sigma bond and the number of lone pairs on the central atom. And from this we can formulate a table. If the hybrid orbitals are 2, the shape would be linear and hybridization would be sp. It means that the valence orbitals would orient themselves at 180-degree angles. Alright. In another case where there are 3 hybrid orbitals, the shape would be trigonal planar and the hybridization would be sp2. Now there can be 2 different cases where there is no lone pair and where there is one lone pair. This leads to different shapes now, but the geometry would be same. In case of one lone pair, the shape would be bent. But when there is no lone pair, geometry and shape would be same. Similarly, we can see the pattern for tetrahedral, trigonal bipyramidal, and octahedral shape. Based on this, you can now solve some questions which have been asked in past examinations. So I wish you all the good luck. Thank you.